Good day everyone, I'm Aflavil Sipadalapat. At this time, we are going to learn about mutually exclusive event. And here are objectives for this lesson that you are expected to illustrate mutually exclusive events, determine mutually exclusive and not mutually exclusive events, find the probability of mutually exclusive events. Recall, we have learned in your past lesson how to compute the probability of an event. To check your understanding about our previous discussion, let's have a review. A standard deck of cards is drawn at random from a standard deck of 52 playing cards. Find the probability of drawing a diamond, a black card, a queen, and a red ace. To find the probability of drawing a diamond, first, we determine how many diamonds from the standard deck of cards. So it has 13 diamonds. So we have the probability 13 over 52 or 1/4. And the same process, probability of getting a black card, it has 26 black cards, right? So that the probability is 26 over 52 or 1/2. The probability of getting queen is 4 over 52 since there are 4 queen of a deck of 52 playing cards or 1/3. And the probability of getting red ace is 2 over 52 or 1 over 26. Now, it is possible that you can turn your head right while turning it left at the same time? Of course not. It is impossible, right? We cannot turn our head right while turning it left at the same time. In our everyday life, there are events that cannot happen at the same time, and we call this mutually exclusive event. What is mutually exclusive event? Two events are mutually exclusive if both of them cannot happen or occur at the same time. And to find the probability of two events, we will use this formula. The probability of A or B is equals to the probability of A plus the probability of B. So we're going to use that formula to find the probability of the two events that are mutually exclusive events. To help understand the definition, it is best to go through a few real-life examples. Let's call two events A and B, and we will see few examples of events that are mutually exclusive and that are not. We have an example. Number 1. A card is drawn from a deck of standard playing cards. Event A, a spade or palo is drawn, and event B, a heart is drawn. Are they mutually exclusive events? Yes, of course. They are mutually exclusive events because they cannot happen or they cannot occur at the same time. Spade at the same time heart. Now, it is possible that the two events both happen at the same time. Yes, there are events that both happen at the same time. Like for example, rolling a die, event A, roll a die and get 2. Event B, roll a die and get an even number. Since 2 is even number from event A at the same time event B, so it can happen at the same time. It can occur at the same time. 2 is even and the event B is even, event A is 2. So this is not mutually exclusive event because it can happen at the same time or it can occur at the same time. Another example, a card is drawn from a deck of standard playing cards. Event A, a heart is drawn. Event B, a king is drawn. It is possible that we can occur on a heart at the same time king. Yes, of course, because the standard playing cards has a king of hearts. So the two events can both happen at the same time, so they are not mutually exclusive events. So let's have an exercise. Direction. Classify the following events as either mutually exclusive or not mutually exclusive. Number 1. The experiment is rolling a die. Event A, the number is greater than 3. Event B, the number is even. Since event A, the number is greater than 3, so the number that are greater than 3 are 4, 5, 6. Since 4 and 6 are even, so it means it can happen at the same time or it can occur at the same time. 4 greater than 3 or 6 greater than 3, and also it is even 4 and 6. So this example is not mutually exclusive event. Example number 2. The experiment is tossing a coin. Event A, toss a coin and get heads. And event B, toss a coin and get tails. So if you toss a coin, you expect that it is heads or tails. It cannot both happen. While tossing a coin, the result is heads and it is also tails. So this example is mutually exclusive event because they cannot occur at the same time. So let's have an example number 3. The experiment is an activity for Saturday. Event A, to segregate garbage. Event B, to burn garbage. Now, can we segregate garbage while burning it? Can you? So it means we cannot segregate garbage while burning it or burning it while segregate. So this event cannot happen both at the same time or cannot occur at the same time. So this example is mutually exclusive event. For example number 4, the experiment is drawing a card from a deck of standard playing cards. Event A, a heart is drawn. Event B, a king is drawn. Now, the standard playing cards have a king of hearts, so it means it cannot happen both at the same time. So this example is not mutually exclusive event. And now, we are going to find the probability of the two events, or we are going to find the probability of the mutually exclusive event. Now, we are going to find a probability of the two events that are mutually exclusive. So now, let's have another example of finding a probability using formula. A probability of A or B is equals to the probability of A plus the probability of B. So, here the example. There are 52 cards in a deck of standard playing cards. Event A, you draw the king of spades. Event B, you draw an ace or alas. So first, we find what is probability of event A and event B. So we have the probability of A, which is 1 over 52, and the probability of B is 4 over 52, or 1 over 13. Using the formula, therefore, the probability of two events is the probability of A plus the probability of B. So 1 over 52 plus 1 over 13. It is 5 over 52. Therefore, the probability is 5 over 52. So again, in our everyday life, there are events that cannot happen at the same time, and we call that mutually exclusive events. That's all for today. Thank you.